In a conventional refinery configuration, DAO from the solvent deasphalter is used to supplement feedstock to downstream processing units, such as the FCC and hydrocracker, to augment the overall yield of transportation fuels. Optionally, it is possible to reject some of the paraffinic white oils in the resid boiling range that may be contained in the DAO by adjusting the recovery of DAO and processing the pitch from the deasphalter in a coker. In this configuration, FCC feed is augmented by coker gas oil. As shown in this table, to compare the impact of various streams on the FCC, workers from KBR presented experimental FCC yields from 3 different feed streams. In case study A, 100% vacuum gas oil, or VGO, 100% deasphalted oil, or DAO, and 100% coker gas oil, or CGO, were used. In practical application, the feed to the FCC is most likely 100% VGO or VGO augmented with some smaller quantity of DAO and/or CGO. In case study B, KBR presented FCC pilot plant data comparing the use of 100% VGO as FCC feed to the use of a mixture of VGO and DAO as FCC feed. Generally, it was believed that Conradson carbon level is an indicator of FCC performance, but the results from both studies show that in a 100% and a 57% deasphalted oil stream, both of which had higher levels of Conradson carbon, had comparable amounts of FCC yield compared to a vacuum gas oil stream, which had less Conradson carbon. Instead, it was shown that FCC yield was correlated with C7 insolubles content. The VGO stream has more C7 insolubles content than the DAO stream, which did not contain any C7 insolubles. The most significant difference between VGO and DAO containing streams was in coke yield. Even though there will be a higher coke yield, processing DAO is still beneficial due to increased FCC feed. Alternatively, deasphalted oil can be used to supplement hydrocracker feedstock. In one case study, a ROSE unit was implemented to process vacuum resid. The deasphalted oil from the unit was then combined with vacuum gas oil and routed to a hydrocracker, which has a low conversion and a high conversion mode, depending on the desired gasoline to diesel production ratio. When more gasoline is desired, the low conversion method is employed and a significant amount of the vacuum gas oil and deasphalted oil remains unconverted in the hydrocracker and is routed to the FCC. In the high conversion mode, a larger percentage of the vacuum gas oil and deasphalted oil is cracked to liquid products in the hydrocracker, reducing the feed sent to the FCC. This table shows the results of the case study, showing the weight percents of FCC feed, naphtha, kerosene, and diesel of the FCC products from 2 identical feeds at low and high conversion modes.